Let's do problem number 4 on the practice final. So here's the question. It says show that 5 is a critical number of the function, and then there is the function. And so remember what a critical number is. It's a number c which is in the domain such that g prime of c is either 0 or g prime of c doesn't exist. Okay, and you know Fermat's theorem tells us that if a function has a local extreme and it's continuous, then the local extreme has to be a critical point. So you can see the one that I just drew is a critical point of this first type, right? But if I do something sharp like this, then this is still going to be a local extreme, but now we're in the second case because this is not differentiable, right? Not differentiable at this sharp point. So, alright, so it's very easy to show that 5 is a critical number. You just have to show that one of these two things is true. So what is g prime of x? G prime of x is 3 times x minus 5 squared. Okay, and now what is g prime of 5? Are we in either of those two critical number situations? Yes, because you can see that comes out to be 0. And great, okay, so half of the problem is done. We've just shown that 5 is a critical number. And okay, so now we're supposed to show that g does not have a local extreme value at 5. So how can we do that? So you can notice that in both of these pictures, if you're going to have a local extreme, here I'm drawing a local max, but it would be the same story with a local min. Let's say that the local extreme happens at this point. You can see that to the left of it, the tangent line is positively sloped, but to the right of it, the tangent line is negatively sloped. And it's believable and true that if a function, you know, is continuous and really close to a local extreme, so if a function is continuous, then really close to any local extreme, the derivative has to change signs. So the question is, does the derivative change signs near 3? And there are, well, how do you prove that it doesn't? The easiest way is just to draw a picture. It's just a transformation of the parabola, right? So here is x squared. This is x squared minus 5, so what does that look like? That's just x squared pushed over to 5 here. Okay, so no sign change happens at 5. This is, you know, it just kind of comes down and kisses 5 and then goes off again. So no sign change means that 5 is not, so there's no local extreme value at 5. So no local extreme value here. What would it look like, by the way? You can see that the derivative is negative to the left of 5, and sorry, the derivative is positive on both sides of 5, right? So it's going to be increasing. This is g. It's going to be increasing because it's positive to the left of 5, and then at 5 it will be 0, and then after 5 it'll still be positive. So we're getting kind of a little cubic curve shape, and that, you know, it's totally consistent with this thing actually being a cubic. And so that's the end of the question.